and we will get started.
Thank you.
So again, we're going to focus today
Yes,
skimmer basin design. I tell you what, I am going to, before we get going, I'm going to turn my video off just because on the recording it'll help with that, and if others as well can stop their video when it records, it's a little better if it doesn't have that. So.
okay.
So we're going to focus today on South Carolina, North Carolina, Georgia, and Tennessee, but this is really applies just about everywhere. As we get started, we'll do a little quick poll. We did focus this on location. So just curious if you can jump in here real quick for those who've joined and just let me know where you're from. Cool. Got a big group in South Carolina, big group in Ohio, and got a few Georgia, North Carolina, Texas. All right, we'll go ahead and end that and share that for those that would like to see it. So I appreciate you letting me know. Kind of helps me gear the presentation so I can focus on those that are able to attend. So real quickly, my name is Jamie McCutcheon. I am a 92 graduate of Clemson with a degree in civil engineering. I founded CCAD Engineering, which was a site planning land development firm in '99. Owned it for almost 20 years and sold it about 6 years ago. I invented the Marley float skimmer in 2013 when South Carolina adopted requirements for surface dewatering, i.e. skimmers. And I'm a licensed engineer in South Carolina, North Carolina, and Georgia. So for the bulk of my career, I've been doing land development and kind of a focus on stormwater. So today we'll go through a few things. We're going to do a quick introduction to skimmers or floating outlets based on location of folks here. I'm going to assume a lot of you are at least familiar with skimmers. We're going to jump into the basics of skimmer design we'll run through Southeast states, South Carolina, North Carolina, Georgia, and Tennessee standards. They're all pretty similar, but there are some differences, just so you're aware. We're really going to focus today on skimmers for post-construction, which is a little new concept. We're going to look at advanced modeling in Hydraflow and HydroCAD, and we're going to wrap up with talking about the Rymar Water Quality Filter and filtration-based design and run through an example of why you may want to consider that for your projects. So like I said, most of us are familiar with skimmers. We used to use perforated risers. Often we had a hole in the bottom, and they would discharge water from the bottom of the basin where mud concentration is the highest. Skimmers have been around for a while. They withdraw surface from the surface or near the surface. What this does is allows the sediment to settle to the bottom. So you're releasing the water from the higher portions of the water column, so it's generally cleaner. The Marley float's a little bit different than some others. We have a debris guard, and our intake is below the surface, so any of that stuff that's floating on the top typically does not get discharged. There are a number of skimmers on the market. Mr. Faircloth started this probably about 25 years ago now. So many of you are familiar with that. The Erosion Supply Company, or ESC skimmer, is fairly similar to the Faircloth. You have the Marley float, which looks a little different. And then you've got the IES. And there may be others. I know there's a Delaware skimmer that sometimes contractors make for themselves. So there's three fundamentals for sediment basin design. So basin fundamental number one is basin volume. So the volume is going to be based on the area flowing to the basin. And the regulations are different depending on where you are, whether that's total area or disturbed area. What we generally see are the regulations are somewhere between 1,800 or 3,600 cubic feet per acre as far as the volume. And then some areas also require basins to have a permanent pool or sediment storage volume that is not drained by the skimmer. One thing to point out here is when you're sizing the skimmer, use that required volume, not the actual volume of the basin to size that skimmer, especially for situations where your pond's going to be a multi-purpose pond and become your detention basin later, because that volume may be much, much higher than your required volume for your sediment basin. Fundamental number two is dewatering time. So sediment basins work by allowing time for sediment to settle to the bottom. What we see as a general standard, it appears in many regulations, is 2 to 5 days or 48 to 120 hours. However, it does vary. Some states don't set a time and others have a little different time. And then third fundamental is flow rate. So once you've got your volume and you know your dewatering time, easy to establish that flow rate. Simply volume divided by dewatering time is going to give you that flow rate. Now, we do recommend that you look at a range of flow rate when you're establishing this, not a specific time. That will make it easier for your contractor. Often contractors may have a skimmer left over from another job. They want to know if they can use that on a project. And so if you want to allow that, it's easier if you specified a range versus an exact, to the point something CFS or so many cubic feet per day exactly. So we'll run through the states in focus today. So we'll talk about South Carolina to start with. So South Carolina's focus is to get 80% TSS removal, that during the construction. They want a discharge capacity based on the 10-year, 24-hour storm event. Again, 3,600 cubic feet per acre draining to the basin. And then they established a minimum and maximum time of 2 to 5 days for your sediment basin as far as the dewatering time. The other thing to point out here on skimmers, just highlight the orifice size and associated flow rates are product specific and should be based off product specific testing. So Georgia also has a similar requirement to this. North Carolina, very similar. Sediment basins and traps that receive drainage from areas of 1 acre or more shall use outlet structures that withdraw water from the surface. Now, what we see in North Carolina is just about every basin does have a skimmer. Some other states have larger minimum requirements for when skimmers are required. Again, you've got a minimum sediment storage volume for North Carolina of 1,800 cubic feet per acre of disturbed area. So only have to count the disturbed area, not the total area. And then they have a minimum dewatering time of 48 hours. And typically, the basin has to dewater from the surface. And then if you're using a skimmer, here's where they state it's going to be a 2 to 5 day time. So you're establishing your volume of 1,800 cubic feet per disturbed area, and then that 2 to 5 day time. North Carolina DNR does say that any skimmer that dewaters from the surface at a controlled rate is acceptable. So there's no specific minimum list or approved list of skimmers for the state. However, DOTs do often have a QPL, which we are on the North Carolina DOT as well as South Carolina DOT QPL. Georgia standards, they're also very similar. Georgia kind of point out back in 2016, when they updated the Green Book or their erosion control manual, they had TRI environmental do testing on a variety of skimmers. And again, what they found was each product and product size has a unique design, and that the discharge rates depended on the specific product and only be determined through product specific testing. And they actually established a testing method for that. Now, for those of you that do work in Georgia or in Georgia, you're used to having this note on your plan. So you're going to have the basin size, your top and bottom width and length and depth, time to drain. We recommend you establish a range of either 48 to 72 hours, like a 1 to 3 days, 2 to 5 days, whatever it is in Georgia that you prefer. Put your skimmer dimensions in there and your manufacturer's name so you know which skimmer you're doing. We would also recommend that you put a flow rate range on here in addition to the time to drain, but that would just help if you do have an equal situation. Again, you're going to compute your minimum storage volume. In Georgia is 67 cubic yards per acre, which is equal to 1,800 cubic feet. And you're also going to determine your elevation for that storage. The rest of this sheet here, I'm not going to go through in detail just because if you're in Georgia, you're probably already familiar with it or it's pretty self-explanatory. But it does base the storm on the 2-year, 24-hour storm event. And then here, Tennessee, their volume is 134 cubic yards per acre, which is 3,618. However, they divide that into 2 groups. They want half of this volume, 1,800 cubic feet, as wet storage, which is basically a permanent pool which does not get discharged. The other, the other half is dry storage. And the dry storage volume is to be watered in a permanent pool in 72 hours. Now, I've had some questions about the 72, if that's a minimum or maximum. And what I understand from Tennessee regulatory folks is that's a maximum. And the requirement is 1 day to 3 days, or 24 to 72 hours is what they look for in Tennessee. And then Tennessee does have the same surface outlets. When discharging from basins or impoundments, utilize outlet structures that only withdraw water from near the surface, unless infeasible. Infeasible is going to be pretty rare. So really quick, just a little chart here to kind of summarize those. Again, going back to basin volume, South Carolina has a 3,600 cubic feet per acre for the total area drained into it. Again, North Carolina is 1,800 cubic feet per disturbed acre. Georgia's 1,800 cubic feet per acre. And then Tennessee has that 1,809, and half of that's wet storage, half of it's dry. They have different surface area calculations. If you run the math on these, they come out pretty similar. As far as surface area, you want to have a kind of a shallower, wider basin just to give more area for sediment to settle. Principal spillway design, it's going to be either the 10-year storm or 2-year storm, and that principal spillway is going to be your skimmer and the top of your riser structure, assuming you have a riser in there, or if it's just a temporary basin, it would be just the skimmer. Emergency spillway ranges from 10-year to 100-year storm, and then where skimmers are required also ranges. Again, South Carolina is 10 acres or more is required. A lot of MS4s prefer it for smaller events or smaller sites. North Carolina goes down to 1 acre. Georgia still does allow a perforated riser, but a lot of MS4s have now said we do require the skimmers. And then Tennessee, it's 10 acres or more, unless it's an impaired, draining to an impaired water body, then it's 5 acres. And then again, our dewatering time, 2 to 5 days. South Carolina, North Carolina, Georgia has no set standard for time frame, and then Tennessee has 1 to 3 days. So one of the big things to point out about skimmers, and it's recognized in a couple of these regulations, is that testing has shown that skimmers, even with the same orifice size, can have significantly different flow rates. So this is a chart from TRI that actually did the work in for Georgia. There are 3 different skimmers here. If you look on the right side, this is a 1-foot depth. 2 of them were very similar, around 37 GPM, and one was double that or nearly double that at 71 GPM. As you see, from a depth of 1 foot to 4 feet, all 3 skimmers had an increase in flow rate of about 25% in flow. And then at a 4-foot depth, again, 2 of them were similar, one just below 50 and one just above 50 GPM. And then the other one again was 90. So the main point here is that if you just specify a 3-inch skimmer, you don't specify brand, you don't specify anything else, you may or may not get what you intended. You may get one that flows. If you intended one to flow 50, you may get one to flow 90. If you intended 90, you may get one to flow much less. So very important to specify that flow rate range on your plans. All right, so we have a simple design tool available on our website for basic sediment basin design. So I've got a box up here that gives your date, project name, your location, company, engineer name, basin description. We've got a little box here to help you with that volume. So one of the things that we see engineers do sometimes and get commented on is not use the required dewatering volume, but use the total volume. So in this case, area to the basin times whatever that volume requirement is for your area. So in this case, let's say this is a North Carolina site, or maybe a Georgia or Tennessee site would be 1,800 cubic feet per acre. It's going to be the required dewatering volume. Then here in the input range, you're going to set your maximum and minimum time. And this is 2 to 5 days. Your pond depth. Now your pond depth is just going to be the depth required to meet this required volume. So if your pond is a multi-use basin, it's going to be 7 or 8 or 10 feet deep, but you only need 3 feet to meet that volume. You want to set that pond depth at 3 feet. You're going to have a top length and width and a bottom length and width. Now, I don't see a lot of perfectly square or rectangular basins out there, so just use your engineering judgment. It's going to calculate a pond volume for you, and you're going to shoot to have that volume, we recommend, within about 5% of your required volume. We're trying to hit a 2 or 3 day range here, so no need to go in here and 120.25 feet and 50.23 in order to hit this to exact. Okay, let's save a little time on that. Then at the bottom of this spreadsheet, we've got a skimmer report page tab, because I know you can't read this very well, but it runs calculations for all of our skimmers. It factors in the flow rate curve, discharge curve for all of those. So based on the depth that you establish, it'll determine the a more accurate drawdown time. But when you go to the skimmer report page tab, it'll print a nice, neat 8.5 by 11. At the top of that will give you your information that you input. So, again, the date, company, engineer, project, basin description. Got a quick check here for the calculated pond volume is similar to the required dewatering volume. And then we help you here with the minimum average flow rate for the maximum time and the maximum flow rate for the minimum time. And then because it is our tool, it's going to tell you the drawdown time for each of our skimmers for the project based on the volume. And then based on the range you set, which ones meet that range that you established. So in this case, a lot of times we try to shoot for a 72-hour time frame. That seems to be kind of the typical. So we'd probably go with our 2-inch with a 2-inch orifice, drain that basin in about 69 hours. If it's a site that you want to get the water out fast for some reason, you can go down here for our 4-inch with a 2-inch orifice, we drain it right in that 48-hour, that minimum time frame. And we also have on our website, we have developed some generic skimmer basin details. So they all have the skimmer sediment basin criteria. You'll adjust this to your area. And the one thing you establish here is that minimum and maximum dewatering time. So you put that right on your detail here, so then that's approved. And then down at the bottom, it's got the drainage area, disturbed area, flow rate that you're basing your design on, the basin volume, your required and provided, surface area, outlet information. Then over here, you get the skimmer size, skimmer orifice diameter, skimmer manufacturer. Is an equal allowed, yes or no? Now, most of the time that's yes. However, there will be some times where you may say no, it has to be the specific one specified. And here you set your minimum and maximum flow rate. And so we've got 4 versions. So this is a version with just an outlet structure, no, just a skimmer and a barrel, no outlet structure there, just emergency spillway. That is basically a dry basin. We have this version and it's a wet basin, so it has a permanent pool. And then we have a version with an outlet structure. We have one with the dry basin or one with the permanent pool. Really the only difference in the permanent pool is we add this sediment storage volume here, so you can include that on your plans. And again, just can't emphasize this enough. You want to make sure that you specify the required dewatering volume and drawdown time on your plan set. So, put this in there either specifically or as that range. So I'm going to ask another quick question here, just so we know who's with us today. What is your role in construction? So I know we probably have a lot of consultants with us, but we do have any inspectors, contractors, MS4 regulatory folks out there as well. Looks like heavily engineers. Majority, we do have a few MS4 regulatory folks with us as well as some inspectors. So I'll end that and share those results. About 82% are with us as consulting engineers today, and about 13% regulatory. Appreciate you listening or replying to that. So other detail here is our skimmer detail. Just a couple of things to point out about it. I know you can't read this block up here, but that is the flow rate for each skimmer with each orifice configuration from 0.1 to 4 feet. We also have, our skimmers have an orifice plate, so we don't have, the other skimmer has a little disc, or some other skimmers have a disc that you cut to a precise size within like 1/10 of an inch. We don't do that. We establish standard orifice sizes, and you use one of those orifice sizes to fit within the range that you're trying to hit for your flow rate or drawdown time. The other thing about ours is our flexible coupling is a little bit different. It's sort of a bellows coupling here. It's a little stiffer. And then one of the big questions we get asked is the length of pipe. So this pipe, we recommend 1.5 times the height of your riser. If you get it out there too far, The buoyancy of the pipe can create some issues with the skimmers, if you get out there 30 feet or something. So typically you don't see this over 20 feet. Most sediment basins aren't more than about 5 or 6 feet deep. So a couple of things here as we wrap up on the sediment basins. This is a photo, I like it, of a newly installed sediment basin. I think the contractor did an overall good job. Okay, they've got their baffles in, have those trenched in. They can see where they've tracked in the sides here to help the vegetation get established. One thing to point out here is this stone pad. We would recommend this be depressed, because what's going to happen is when it rains, you're going to have 6 to 8 inches of water that's going to have a really hard time getting out of this basin. And so as you try to get grass established on the site, it's going to be difficult to do so. They do have their clean out stakes set here, so they kind of have a reference point for when to clean it out. So if it's getting a lot of sediment, you don't get grass anyway. But if you're trying to get grass, it will help to depress that and get the water out of there. Now, this is probably one of the worst installs we've ever seen. So contractor, I think this was an Ohio project. There's no flexible coupling. I'm not even sure how they connected that to that valve cover there. They've got the valve on this side open, so there's probably almost no water going through the skimmer anyway. Just overall, a really poor job by the contractor to put this in place. We have seen some installed upside down. I'm not sure what they're thinking here. And also, I guess the good thing is they didn't put enough pipe here for this to flex up very much. So the pond's going to drain out fairly quickly anyway. But just kind of being aware, sometimes contractors do contractor things, and they don't get installed right. And then also, skimmers are not maintenance free. This is another skimmers on an engineering project we worked on actually had vegetation growing out of it. So if you see vegetation growing out of the skimmer itself, probably is a problem and going to need some maintenance. All right, so that's going to kind of conclude our initial talk on sediment basins. If anybody has any questions, again, feel free to use the chat or send an email. Lynn is monitoring that. So I want to ask really quick here, another question with you. Have you ever used a skimmer for permanent use? So majority looks like no. Good. Got a couple of people that said yes. That's uh, exciting that we're promoting that and starting to see a little bit more of that. Um, there we go. Got most people participate. So we had 75% say no, have never considered that. About 10% have said they considered but haven't done it yet, and almost 14% have said they have done it. So that's cool. I'm glad to hear that. So we're going to talk about why you may want to consider a skimmer for permanent use. So our typical dry detention basin, okay, your skimmer is going to get removed once the site stabilizes. You're going to put some sort of low flow orifice installed at the bottom of the riser to release that first flush storm event. So that's typically how we do water quality. We're trying to hold that first flush for some amount of time. And the intent is, again, to get the pollutants to settle to the bottom of the pond and not get discharged. And then you're going to usually have some sort of guard or filter to reduce your clogging, because a lot of times, especially on smaller sites, these orifices can get pretty small. I know some regulations don't like to see them smaller than 3 inches, but even a 3-inch orifice clogs pretty easy. And so you need something there so it tries to function as best it can. So, basins are relying upon natural settling of sediment particles as they travel from the inlet to the outlet. And as we've established, skimmers release that cleaner water from the surface. Most places now, they've become very accepted for construction. And so, common sense kind of jumps in and says, well, if they're so effective for construction, why wouldn't we want to use that post-construction as well? If you're settling everything to the bottom of the pond, but then you're then discharging from the bottom of the pond, seems like could be a better way to do things, and maybe use the skimmer post-construction wise. So if for nothing else, skimmers can help with maintenance. So this is a little case study site we did not too far from our office, about 20 minutes away. This site was let's just say ignored for many, many years, probably 20 years of no maintenance on this pond. We got a notice of violation. We went to the owner, helped him clean it out. literally cut the timber. As you can see, we left some large trees in there, but we cut 8 and 10-inch trees out of this pond that had grown in over 20 years. And it would look like this. It would hold water. We didn't think it was supposed to be a wet pond, but we weren't sure. But it had these orifices here, but it didn't have a low flow orifice on it. So we redesigned the pond, put in a skimmer. What we found out was that, in fact, and this picture on the right is the best one, there is a 2-inch orifice 6 feet below the now bottom of the pond at this time. So we redesigned this basin, and instead of putting the 2-inch orifice down at the bottom, which we knew would be a nightmare to maintain, we got approval as a pilot project to install a skimmer as the low flow orifice. So we installed a 4-inch Marley float. This was our older model at the time, and we had to monitor it monthly and give reports to the county to make sure it was working. Almost a year later, maybe 9 months later or so, the current owner decided they were going to keep this pond maintained. So they had landscapers go out and cut the sides of this pond. This pond is about 3/4 of an acre in size. It has 1.5 to 1 side slopes, so pretty steep. So the landscapers cut everything, let it fall to the bottom. And before they could get it out, we had a 5-inch rain that pushed everything to the outlet. But you can see here, Marley float's still sitting down in the muck there, but did manage to drain the basin. If it had gotten clogged, it'd be pretty easy just to pull on the rope and shake it out or get to it on the surface. If you can imagine a 2-inch orifice down here with all this debris, surely would have gotten clogged. And this picture on the right, that is about 8 or 9 feet of elevation difference there. So just getting to something at the bottom here of a 2-inch orifice would be dangerous, to say the least, and very difficult. So just from a maintenance standpoint, may want to consider skimmers as your low flow orifice. So if we're going to do that, how do we do that, right? So now that Autodesk owns Hydraflow, that seems to become the most common hydraulic modeling program out there. So we're going to run through a quick example of how you would model a skimmer in Hydraflow. So this is actually a site that I worked on in the city of Greenville, South Carolina. The city of Greenville requires quantity control during construction. So it's a complicated little structure for a pretty small site. So got about 5.5 acres, about 3.4 were not being disturbed, about 2.2 were being disturbed, going to this little sediment basin here, and then discharging to the study point. So pre-development had an area of 5.53 acres, curve number was 59, it was a wooded site, time of concentration just under 20 minutes. Post-development, the undisturbed portion stayed the same. The disturbed portion was 2.23 acres, curve number of 86. That was a disturbed bare earth condition during construction. Time of concentration down to 7 minutes. So first thing you want to do here is you want to build your pond. So when you build your pond, you need to include a stage here to be able to enter the skimmer data. So for this example, I've done it at 0, 0.1, 0.3, 0.5, and then a half a foot up to 4 feet deep. This pond just happened to be a 4-foot deep pond. This will allow us to be able to put in skimmer flow data later. Again, the flow data that we provide matches that 0.1, 0.3, 0.5, then every half a foot up to 4. And so when you build your outlet structure, you're going to put in your 18-inch barrel. That's pipe going out of your basin. In this case, we had a 6-inch orifice, 1.75 feet above the bottom of the pond. Had our riser structure, about 3.6 feet tall, and a rectangular weir 3 feet, so a 1 foot wide rectangular weir there. And then here, kind of the secret sauce is this user-defined column. This is where you enter the skimmer flow rate off of the detail. So just manually enter that at the stages that you created to build in that flow rate curve so Hydraflow will model it correctly. So Hydraflow will interpolate between the entry points. If the basin is over 4 feet deep, you can either use the flow rate at 4 feet of depth. You can extrapolate it yourself. If it's only 5 or 6 feet, you can probably just kind of maintain that or extrapolate it out. Or if you want to get really precise, let's say you've got an 8-foot deep pond, go back to our design tool and it'll break that 8 feet into 20 increments. And then it'll provide the flow rate for each skimmer at at those increments. You can then, adjust your increments in your basin when you put that in and plug that rate in. Now, this example, this is our 2-inch skimmer with a 1/2-inch orifice, so you're not seeing much change in flow rate, but on the larger skimmers, you're going to see a bigger change of that. And so then when you look at your schematic in Hydraflow, typically you'd see a low flow orifice down here, 2 or 3-inch hole at the bottom. You don't have that. You've got your 6-inch orifice, your rectangular weir, top of the riser. But when you look at your stage discharge hydrograph, you've got flow coming out. This little green line is the flow from the skimmer itself. And if you look at your flow table, you'll see that the total outflow is matching the user-defined flow up until 2 feet, which is where that 6-inch orifice kicked in. And you can see the other outlet structures kick in as well. So just showing you that it does model it in there and how to plug that in. So the other program that I like to point out is HydroCAD. We actually have a relationship with HydroCAD, and the big difference between HydroCAD and Hydraflow is HydroCAD's a smaller company, and they've reached out and incorporated multiple proprietary products into their software. So when you're building your outlet structure, we've got a riser in here. Then we do this special and user-defined outlet. When you click on that and you go load from file, it's going to take you to a folder that's going to have a bunch of proprietary products in there. The Marley Float's one of them, and they're going to have an Excel file for each skimmer with each orifice configuration. And so all you have to do is click on that, and it will fill in the discharge for you. If it's over 4 feet, you can set it to extrapolate. It'll do that for you. If you got a huge pond and you need 2 or 3 skimmers modeled, you can do a discharge multiplier. So some cool features in that when you use HydroCAD. So just something to be aware of. Don't spend a lot of time on HydroCAD because everything else is pretty similar to Hydraflow. So any questions on either the sediment basin design or the post-construction kind of permanent skimmer modeling for that? All right, hearing none, we'll move on. So kind of the big thing we want to talk about now is something that maybe a few of you have heard of, but we're really it's a focus of Rymar for this year and probably for the next few years to really get the word out here. So we're going to talk about using advanced skimmer modeling and filtration-based water quality. So going back to that pond we showed as the maintenance example, we've kind of used that pond as our playground sandbox, so to speak. So it's been our R&D site. So we had developed over, it took about 4 years. We developed a prototype. And we have a 2-stage filter system. So the outer stage here is just
70 participants in the meeting. This meeting is being recorded.
Sorry, guys. I don't know if y'all can hear that or not, but heard something there. So anyway, so we've got our 2-stage filter. The outer stage is a polypropylene filter. It's basically a Mirify woven geotextile. This inner fabric is a material called Adsorbate. It'll absorb hydrocarbons. It helps some with metals as well as other pollutants. But looks like that. Kind of look up close there. So we modeled this or prototyped this out there for about 2 years. This is the actual outlet. If you look here in the pond, you can definitely see a turbidity difference on the water in the pond versus the water that's inside the filter. And then if you look here, this is the flow coming out of that pond. Now I probably wouldn't drink it, but it's definitely, pretty clean water when you see coming out of a pretty dirty sediment basin or stormwater basin. We've now done third-party testing, and we have sorry, I got a little background noise there. So we got a little third-party testing, and our third-party testing has shown we've gotten over 90% TSS removal with the combination of the skimmer and filter system. So one thing to point out about our testing, we had TRI Environmental do the testing for us. They tested it in accordance with the ASTM standard. The standard is C1746 for sediment retention devices. We set up the tank to minimize the effects of the pond. So we introduce sediment laden water here within about 1.5 to 2 feet of our filter, and then had the skimmer pull that water through the filters to be discharged. So what that does is that took out the benefit of a forebay. It also took out the benefit of travel distance from the inlet to the outlet. So really, we tested this in a worst case condition. We tested it as a dry pond. So they started off dry and filled the tank up, then drained it back down our assumption was that a dry pond does not function quite as well as a wet pond, which
Yeah, I
seems to be
spoke
a
to Andrew
standard out there.
this morning, and he said he was unavailable to make the meeting.
So, sorry, I had a little background there. Do that. So we now have this commercial version installed in the pond. So this is again that same pond. Just kind of gives you a better picture of the shape and look of that pond. And I will point out this is in a watershed that has about maybe 30, 40 acres draining to this basin that has very little other stormwater management in place. It is in a highly developed commercial area. There's several shopping centers upstream of this. There's even a electrical substation right off the interstate. So a lot of pretty dirty water coming in and collecting in here. And that's what our version looks like. So this is our latest skimmer. That's our 4-inch skimmer. This is the woven polypropylene on the outside and the adsorbent fabric on the inside. So let's talk about why you may want to do this. So what are some benefits to filtration versus settlement? So if you use a filtration model, your peak rate of discharge is based on your filter treatment flow rate, basically up to whatever your first quantity storm event is. So in most cases, that's a 2-year storm. And so if your filter can handle it, you can use that as your outlet to go and treat up to that 2-year storm rate. The filter is going to treat 100% of runoff from storms up to that peak rate. So, we as engineers and regulatory folks understand that water quality is not really simple, right? And for when we do a stormwater basin design, we typically assume a first flush volume and release that first flush volume over some period of time, 24 to 48 hours. But what happens when we get a 1/4 inch of rain over 4 hours, but it comes down hard enough to wash off the parking lots, right? That's basically going in the basin and going out. And so if all of our water quality treatment is based on settling and we're not getting any ponding, we're not getting much settlement. So advantage of the filter is even those trickles are going to go through the filter as well as up to whatever that peak rate first quantity storm event is that's being covered. And then lastly, your filtration media can be customized to target specific pollutants of concern. As I mentioned, the adsorbent fabric we use will absorb hydrocarbons, has some testing on metals. We're working on nitrogen, phosphorus. Those are a little harder to do, especially in dissolved circumstances. But a lot of times those attach themselves to sediment particles. So if you're getting 90% of the sediment out, you're also getting a large amount of the other pollutants out as well. So again, some benefits to filtration versus settlement. Oops, duplicate slide. There we go. So now let's talk about benefits to using skimmers with filtration. So our skimmer can be sized to control that peak rate for the lower storm events. Again, depending on the size of your site, you can probably control maybe up to the 2-year storm with a skimmer. The skimmer is going to increase that filter efficiency because now you're withdrawing from the surface where the water's cleaner. So you're not pulling it off the bottom where you're trying to get all the pollutants to settle to. You're actually, withdrawing that water that's higher in the water column. So it's cleaner water to start with. And then skimmer is going to be easy to access or pull to the side of the pond for maintenance and changing the filters. There are some challenges to using skimmers with filtration. Number one is filters are prone to clog over time and will require maintenance and periodic cleaning or changing. Skimmers must be durable and last more than a few years to be suitable for permanent use. A lot of skimmers on the market are more PVC products. There are some others out there that are maybe more designed to be permanent. Marley Float is an HDP product, so it's a 20+ year life of the skimmer itself. So, we're confident in using it for post-construction. And then the biggest challenge we have, and for those MS4 folks on here, There are no established standards for basis of design and permitting based upon a combination of pond and filtration. There are some standards out there for using what they call MTDs or mechanical treatment devices, proprietary devices, other type things that a variety of manufacturers have come up with to be able to meet water quality requirements. Very few of those, if any, have been designed to be used in conjunction with a pond. And the ponds typically have standards for first flush withdrawal. We do have one question that said, what type of skimmer would you use with a larger storm event? You probably can't. A skimmer's, the flow rate of a skimmer is going to be probably 2 CFS or less. Our largest skimmer, our 8-inch max, has a flow rate of about 1.8 CFS. So, a 25-year storm event, obviously depending on the size of the site, if it's a 1-acre site, you might be able to handle that. But, 5 or 10 or 50-acre site, obviously, you're not going to do that. So you're going to focus the skimmer on whatever that lowest quantity event is. Like I said, normally it's a 2-year storm event. Some places have like a velocity requirement or low flow requirement that they may do. Regulations vary so much, it's hard to say kind of one size fits all here, but just want to give you the concept of doing that. So we're going to jump in and look at a model here, or a sample of how you would model the traditional first flush release over a filtration based, flow rate of filter product, and kind of how it would differ as far as your pond size and obtaining water quality. So let's look at a sample site. The size of the site is going to be 5 acres. Well, let's assume a pre-development condition, fully wooded, curve number 55. Post-development, we're going to a shopping center. We're going to do a 92 for commercial. So the first thing we're going to do is we're going to determine our pre-development flow rates. So based upon the 5-acre wooded site, we kind of did a guesstimation time of concentration of 48 minutes. 2-year storms only going to release 0.72 CFS, 3 for your 10, 5.4 for your 25, and 10.7 for your 100. We're going to focus on the 2-year event for this, since that's really what we're going to work on with the skimmer. So step 2, we're going to look at our water quality volume and our post-development flow rates. So based upon the 5-acre commercial site with time of concentration of say 10 minutes, we're going to calculate a water quality storm event and post-development flow rates. So I did this based on South Carolina. So the water quality storm here is 1 inch of runoff. It's going to a dry basin. And so for this site, that'd be about 18,150 cubic feet. If you're in Georgia, that's going to be 1.2 inches. If you're in Tennessee, I understand it's 1 inch of rainfall. And if folks in Tennessee want to correct me on that, please let me know. And in North Carolina, I believe it's either 1 inch or 1.5 inch volume. But anyway, for this event, I'd used a trial and error and determined that a 1.73 inch 24-hour storm would approximate that 18,150 cubic feet. And for our developed site, that's going to generate 7.2 CFS. Our 2-year flows just under 20 CFS, 10 years just over 30, 25, 38, 153. So again, we're going to focus on the water quality storm event and our 2-year storm event for this example. So what we see in most cases is a traditional design has some sort of spreadsheet or calculation to determine what our first flush orifice should be. So we've got a dry basin here. We've got a contributing area of 5 acres. That 1 inch of volume is 18,150 cubic feet. And we're going to release that over 24 hours. So one of the fallacies here is poof, magically that full water quality volume hits the basin instantaneously and then slowly drains out over 24 hours. Obviously, we know that doesn't happen, but that's what we base it on. But if that were to happen, a 2.6 inch orifice would drain that volume in 24 hours. So for the modeling example, I assumed that a contractor would not readily be able to put in a 2.6 inch orifice, so I went with a 3 inch with a trash guard. And then the bottom of my basin here is at basically 110. We've got that water quality volume of 18,150 cubic feet. So that requires about 3 feet of depth in my hypothetical basin. So my next orifice has to be at least 3 feet, has to be above that. Can't have an additional orifice releasing that water quality volume. So we put a 3-inch orifice at 113, an 8-inch orifice at 115, and my top of risers 117.5. And then this is what it generates. So our peak flow rate leaving this basin, our water quality event is 0.25 CFS. And in the hydrograph's only using just under 11,000 cubic feet. So, we're required to have this 18,000 cubic feet of volume in the basin, but we're really only using 10,700 or just under that in the pond to control that storm event. And then our 2-year storm has a release rate of 0.81 CFS, which is just over that 0.72 pre. Again, depending on where you are and your MS4 requirements, they may or may not allow a 1/10 of a CFS increase. But for this example, I kind of assume we did. And then this is the storage required for each storm event based on that traditional design. And just kind of we'll save that for future reference. So as an alternative to that, let's look at how we would do the design with a skimmer with a filter. So what we're going to try to do is we want to determine a skimmer that could control our 2-year storm peak flow rate, because that is the first storm event, at least in South Carolina, that's regulated to control. So what we're going to do is we're going to say, hey, that's a 0.72. The 6-inch skimmer with a 6-inch orifice has a flow rate, peak flow rate, and that's at a 4-foot depth of about 0.78. And so we're going to say, hey, let's try that one and see what works. So this is the detail for this filter. So a couple of things to point out with this. Number one, in our other basin details, we showed this kind of turned and running parallel to the bank. For post-construction, we probably don't want to do that. We want it sticking out into the pond, kind of get it away from the banks. The reason we want to do that is these filters do get fairly big depending on the size of the skimmer. So our 2, 3, and 4-inch, the inner skirt is 5 by 5 and the outer's 8 by 8. And so really you've only got 4 feet of skirt from here to here to come back towards your outlet structure. So as long as you've got, say, at least an 8-foot length barrel, and assuming a 45-degree angle on that, that filter's not going to hit the riser. However, when we get bigger, our 6-inch, 8-inch, or 8-inch max, the L1 and L2 start differing. That's because we need to maintain a total surface area for the filter as well as length of the filter. So what we did when we sized these is based on our testing, we determined a maximum flow per square foot of filter, and we scaled the filters to meet that, assuming that all the water goes through the filters. We also determined a maximum flow per length of filter. Let's assume that the filter was clogged and you had to maintain that flow rate, going under the filter, because these filters basically hang 3 feet deep in the pond, but they are open on the bottom. So water can come there. So what happens is we allow gravity to do the work. If any water is coming from 3 feet below and back up to the skimmer, we're going to assume, well, actually we know from our testing that the flow rate, the force of that flow is not enough to pull that sediment particle back up to the top of the pond. So again, this is the detail for the basin itself, has all standard information in here. Again, there's some cases you may do a flow rate range, or, and for post-construction, you've probably got a maximum skimmer flow rate or minimum, so you're trying to hit your pond design. So if you run this through the model, what you're going to see is our water quality event is now getting released at 0.7 CFS. So remember before that was a 0.25. So what we're doing is we're releasing that water quality volume nearly 3 times as fast. So what does that do? We use much less of the volume of the pond. So now we're only using 7,600 cubic feet of the pond volume for that. We then say our 2-year storm is at 0.78 CFS, so a little bit lower release rate than our 3-inch orifice before, but it's being controlled by the skimmer. So now what's happening is up to this 2-year storm event is not only being controlled by the skimmer and doing our pre versus post, it's also getting treated by the filter. So now we're treating much more of the annual rainfall by going through that filter and a much higher rain events. In this case, I think it was like a 4 4 point something inch rain for 2-year storm. Peak elevation for the 2-year storm is 14.7. So we go and set a 8-inch orifice at 114.8, and then control our our 10-year and 25, 50, and 100 with that. And our riser structure gets a little, not quite as tall too. We're able to reduce that about 1/2 foot. So then if we look at comparing the storage required for our pond with a skimmer versus traditional pond, you'll see it's much less. And just to make it a little simpler, we've got nearly 30% difference in storage required for the water quality event, 14 and 12%. So what you've done is you've reduced the size of the pond, you have treated more of the annual rainfall, and you're treating it to a higher level of treatment, getting that 90% TSS based on testing. So hopefully that makes sense. Any questions on that methodology or anything? And then I'm gonna launch one more poll here.
Yeah, one question is regarding any studies regarding the cost of the skimmer maintenance for any size?
Yes, so for maintenance, that's a great question. Based on our prototype, we have confirmed that the materials will last at least 2 years. And so right now we are saying that we would recommend replacing the filter every 2 years. Based on the prototype we did, the filters were still functioning very well after 2 years. They definitely had collected a lot of sediment and other particles, in the filters themselves, but they were still allowing flow through them. So I'm gonna end this poll real quick and share that. So, about a third of you say, yep, that's a good idea. And about 65% say maybe for the right project. And we 100% agree with that. This is not a use for every project. There's, definitely it's a tool in the toolbox, what we're trying to do. Got one person that says they should just be temporary, but I understand we're going to have some differing opinions on that. So also have a question in the chat. It says, with the higher TSS removal, have I tested phosphorus and nitrogen? The answer is no. And the main reason is there's not a standard developed yet for that. That's not an easy thing to test, especially in a lab. And as to the best of my knowledge, there's not an ASTM standard for how you would do that, what the inflow rate, outflow rate would be for that. We are working with a couple of universities. We're talking to Clemson University, Auburn, and Tennessee about doing some field testing. And in those cases, they would test for a variety of pollutants, including phosphorus and nitrogen. And if anybody on the webinar here today is affiliated with any of those folks, we'd love to partner. We'd love to find a master's student that wanted to kind of do this for this master's class. If we found somebody in the Greenville area, we've got a pond set up, ready to go. Would love to do that testing there. We are working with GE. I mentioned we just installed our filter at the GE campus. They have put our skimmers in most of their ponds, generally for maintenance. They were just having some challenges with maintenance there. And we just recently installed the filter around one of those where they were having issues with bacteria. One thing I failed to mention on our fabric is we actually use a fabric that is treated with an antimicrobial. And so not only are we going to have, the filtering and kind of just screening out the sediment particles, but it is an antimicrobial treatment that will help some with that. Now, we don't know about contact time and that kind of stuff, so we aren't making any claims on that yet. But that is something that we're hoping GE is going to be doing some testing and hopefully give us some feedback.
You didn't answer the question regarding is the 5 acre is the size of the pond or the size of the whole site?
The whole site. So the pond
Okay.
would,
Out of
your
that,
pond's just
what percentage is the pond and what percentage is the site? Is that developed site or underdeveloped site, or that site is fully developed and
So
there's
so
runoff?
the sample project we went through would be a 5-acre fully developed site. So going from a wooded to a commercial site. Um, honestly, I don't remember what the area of the pond came out to be. Exactly. I could look that up and tell you when I ran that model, but it would be, you know, similar to a traditional detention pond, except that by discharging the water quality volume through a filter and therefore allowing it to relieve faster, the total size of that pond is going to get reduced about 15 to 20%. So you're going to gain some area to add a couple of parking spots, maybe a little additional building, or, you know, if it's in a residential area, maybe get an extra lot out of it.
Okay.
All right, so we're going to wrap up here. We've got just a few minutes left to go. So this is our website, rymarwaterworks.com. On our website, we have on-demand webinars. So we will actually be putting this one up on our YouTube channel. We have a training series. So we didn't get into it today, but you know, some places use SEDCAD for sedimentology modeling. We have a tutorial on SEDCAD. We got a couple of tutorials on our design tools. We have a couple on the permanent use of skimmers and the filtration. So that goes a little more of a deep dive on those. We have a simple zip file, it's our engineer spec pack. So when you download that, it's going to be a zip. You can extract it, and you're going to have all the Marley Float skimmer details, design tool, test data, supporting information, maintenance recommendations, those kind of things. We'll have our standard sediment basin details in a folder, and then we'll have the water quality basin details, the design guidance, our TRI environmental test data, and supporting information, maintenance recommendations, such on that. So make it really easy if you decide you want to incorporate this into a project. So couple things about the product itself. Again, it is made of HDPE, polyethylene float. It's very UV resistant. It's fabricated to be the permanent outlet structure. When I invented this back in 2013, part of the vision was, hey, let's have something that can be used permanently. And it has, no moving parts. That one piece that pivots, but other than that, everything's just stationary. So nothing really to break. We have our debris guard here, so that during construction that traps or keeps the seed and straw. All that straw runs down into the pond after the first rain. If you had let's say you had a diesel spill, somebody hydraulic line broke or something like that, that gets into the pond, that's going to stay at top, so it won't get discharged to the skimmer. For most people on this call, I can say it works in frozen conditions. We'll call it mild frozen conditions. If we have folks in here from Ohio or somewhere, the Cleveland area, and you get a foot of ice during the winter, well, nothing's going to work in that top foot, right? But generally, it's going to continue to work even in mild frozen conditions. We mentioned earlier our orifice plate. So this is an example of that. So it's just a rubber plate, cut with different size holes. We've got this little nub here in the bottom that just makes sure it gets centered back over the orifice correctly. So, each one of our skimmers is going to have 3 to 5 flow rates in each device. All of those have been third-party tested to verify the flow rate and drawdown times. And then, we did redesign our skimmer about 4 years ago. So you've got 2019, 2020 timeframe. Before we were having some installation issues where it was a little top heavy, and if it wasn't installed correctly, it could turn or flip over, really just turn to the side. And so we adjusted that. We moved all the weight to the bottom. And so now it always stays level, always floats correctly in the basin. We have our 6 and 8 inch, now our 3 and 4 inch actually too, come in our custom molded float. Our 6 and 8 have handles built in. Because we're holding our orifice underwater, and you've got a 6 to 8 inch pipe that could be maybe up to 20 feet long. Once it gets up to a 45-degree angle, it is basically full of air, and so there's a lot of buoyancy. So these are heavy. They weigh about 240 pounds or so, and so we've got handles in place to make it easier for them to carry them. And then these are our 6 models. So we have our 2 inch, 3 inch, 4 inch, 6 inch. We have our standard 8 inch, and then we have our 8 inch with 8 inch pipe. We call it our 8 inch max. Again, that skimmer has one of the highest flow rates out there of almost 1.8, just over 1.8 CFS. The reason we use a 6-inch pipe with our 8-inch skimmer is because we got high flow rates. In this version, that 8-inch does over 1.5 CFS. But we were able to lighten it up for shipping and just ease of handling by the contractor by having to maintain that 6-inch pipe underwater, not an 8-inch pipe underwater. And hit the 12 o'clock on the dot. So really want to thank you for attending the Skimmer Sediment Basin Design webinar. If you would like a PDH certificate for attending, please just email us at info@rymarwaterworks.com. Lynn and Meredith are on the call as well. They will be getting those certificates out to you. I know if many of you are like me, got a renewal period that's coming up at the end of the month. So it's nice to have a PDH to help meet those CEU requirements. So if anyone has any other questions, please unmute. Be glad to answer, or you can use the chat box.
Yeah, if you can send us the PDF version of your slides by email would be nice.
Yeah, we'll be happy to do that. I'll create a PDF of the PowerPoint, and it'll probably be a pretty big file, so I'll create a link to that. And then also, if you signed up for this, you'll get a link to the YouTube channel for the video that you can refer back to. And then I'll just say, we went through a lot of this pretty fast. A lot of this is just intended for an overview and make you aware. If any of you have that you would like to use that you're like, hey, has this been accepted by whatever MS4? Please let us know. This is new. We do not want to delay your project, and we will make sure we get in touch with the MS4. We've already had several conversations with folks in Georgia. Forsyth County, I know is one that we've talked to extensively. There's a consultant that does review for several counties or MS4s there. We've had discussions with them because we've got an engineer looking to use it there. So we'll help you, plow that ground. We're not looking, for engineers to have to do a lot of work to get something new approved. Believe me, I understand that. We got to, permitting takes long enough. Don't want to slow that down, but we do think we've got a good, innovative solution that can be the right fit for a lot of projects, especially retrofits. I didn't talk about that much, but if you're going to do a retrofit on, say, a developed area and it's got a pond that didn't have water quality, and now you've got to meet water quality requirements, right? And you can't do that because you can't get more volume in that pond. Well, adding the filtration system and maintaining that 2-year storm event could be a great solution, very effective, very low cost. Didn't mention cost of the filter product. Our skimmers range in cost from about $600 to just over $6,000. We're very competitive with other products on the market, typically a little bit less expensive. And then the filter, it's going to range from about $3,500 up to maybe $10,000 or so, depending on the really large sites. So if you compare that to other methods, like hydrodynamic chambers or vault systems or any of those other kind of water quality things that in areas where a dry pond doesn't meet it by itself, right? I know Tennessee, dry ponds don't meet your full water quality requirements. Some other states were kind of exploring that. And so that can be an extremely cost-effective way to get you up to that 80+% or 85+% TSS removal. So again, thank everybody for attending. I know coming back from a holiday weekend, you had a lot to catch up on. And so for you to take an hour of your time is really appreciated. And we hope to talk to you soon.
Thank you.